Andrew Irvine. Hello, chemistry teacher, AP chemistry teacher. How are you?
Good, Peter. Thanks for having me today.
Thank you for being here today. I appreciate it. We are going to jump right in. I think everybody knows what we're about to do. And why don't you start by just telling us about yourself?
I grew up in Connecticut and I moved out to California for my first teaching job at Idlewild Arts Academy. Actually, my second teaching job, but that got me to California. And then I came to Harker in 2007, and I've been here ever since. This is my 18th year teaching chemistry at the Harker School in San Jose. I went to Brown University, got a BS in chemistry and a BA in visual arts. I still do ceramics to this day, which was my primary passion beyond chemistry. I actually did classes at Rhode Island School of Design and would bring down chemicals, and they called me the crazy chemist. And I'm like, look what I got. We can put this in the glaze and see what happens. And then post-college, I was trying to figure out life and started tutoring and working at different local schools in Rhode Island. And the snowball took me to where I am today.
And snowball took you to where you are today. And Harker, you said, is where?
San Jose, California. So in addition to teaching chemistry for 18 years, I've coached girls lacrosse here. I am the K through 12 sustainability coordinator. I'm also a spirit coordinator. We're in Spirit Week right now, which is I'm supposed to be dressed like a kid day, so that's why maybe a little bit less formal than usual. So I'm actually the longest running chemistry teacher at the Harker Upper School right now.
Very nice. And tell us about the school a little bit, Harker.
Harker's K through 12, actually TK through 12. So we got 4 different campuses, and it's a private school in the heart of Silicon Valley that certainly does more than STEM, but well known for STEM. And on the research front, we've had a lot of Intel and Siemens winners. But really, I like to say it's a school for kids who value and families who value education and want to challenge themselves and have high standard academics, both in STEM, chemistry, but other subjects as well. And so I guess the upper school has been here since 2000. And I joined in 2007. I love it.
Very nice. Very nice. Andrew, for the benefit of those here who are new, class companion, and I know you know this already, it basically does 4 things. It helps, let me rephrase that. It helps teachers to assess SAQs, LEQs, and DBQs. But it also helps with checks for understanding. The teacher uploads an assignment and can create a check for understanding. So what I was going to ask you here to start this thing off is, of the 4, have you ever used it for checking for understanding?
Well, it's my primary tool. You introduced it to me, about, I think, 2 months ago, and I've been trying different experiments. This year, I'm teaching AP chemistry to juniors and seniors for the first time. Previously, we have a sophomore AP chemistry program where students who do very well in honors physics can take AP chemistry as a sophomore, which is unusual. I also manage and run the summer program, which is a bridge for that. But seniors, second semester seniors especially, are a new part of my career here at Harker, and keeping them focused. I've used different tools throughout the year, one of which is like an exit ticket where they can get maybe 1 extra credit point on a future assignment if they demonstrate that they have paid attention. And it's not like I'm giving them like super calculus. It's like, hey, here's this. We've been talking about it for like 75 minutes, 10 minutes. Here's a problem. And Class Companion took that and made it to a new level from my perspective. It can generate the problems based on the topics and take it, but essentially it's an exit ticket / extra credit quiz, and it gives me feedback right away.
So I'm going to have you demo that in a second, if you wouldn't mind.
Sure.
Just take over the screen. But before then, before I introduced Class Companion to you, what did you say? That was about 4 months ago. Had you used the platform before that, or was that the first time that you learned about how to use it to check for understanding?
I hadn't been using Class Companion. I've been using AI for AP chemistry and my other chemistry classes since OpenAI came out in the scene, right? But not Class Companion.
Oh, cool. So let's just see how this works for you as a relative newbie. So can you take over the screen and
let me do that.
Walk us through. And are you doing this check for understanding after you teach a topic? Is it after you show some kind of explainer video? Let's see where that goes here.
Yeah. So essentially, let me get this share up. Let me know. It always takes me.
Okay, here it is. I got it.
Okay, cool.
There you are.
So right now I've got a couple. Go ahead.
So this is your class companion dashboard for your class right there.
Correct.
Oh yeah, I see it. APChem. Good. Okay.
Yeah. So I made it for my honors chemistry too, but I haven't explored that yet. And I tried different versions. So you can put in a prompt, and the AI system can generate the questions for you. You can write them for yourself. I think they also have a library of content you can choose from. But one recent one I did was oxidation numbers and voltaic cells assignment. So the gist of it is that I start with my lesson, right? And it's not the first time I'm introducing this concept to them. It was the beginning of in the AP chemistry units, unit 8, which is electrochemistry. But we've been talking about some of these topics throughout the year. And so I had my class where I reviewed those topics, consolidated them, and then bridged them to the new part of the Unit 8 in AP Chemistry. And then students have been conditioned now, I hope, to expect that sometimes, unexpectedly, from their perspective, I will have this extra credit quiz. And and I've migrated them to use this. So at the end of class, I said, okay, guys, take out your computers. You got 10 minutes. Go. Right. And so there's different tools here, but I can go through the students' details one by one and see how they did. But in terms of the assignment itself, I inputted, I wanted oxidation numbers and a voltaic cell, E cell. And so I just put that in, and it generated these details, which, you certainly have to edit and make sure with any AI system that it's met what you want and your intended outcome. And these are the questions that it generated, and students were pretty successful. So let's try a ticket.
Let's try something together. I am not a chem guy. So scroll back up to the top there for a second. And now let's think about next week sometime. All the AP courses, they have topics. What topic are you going to teach next week? Where are you at in the course? Give me a number.
Well, today we did, we moved beyond the standard cell potential, and we're starting to do non-standard cells. And then once a little bit more practice, then we're going to move on to electrolysis. But for today's lesson, which was actually an hour ago, I did non-standard cells, and so we use something called the Nernst equation. So do you want me to try it out right now and see what it comes up with?
Does that in AP Chem, or do you teach, does it have a specific topic number like 7.3 or something like that? Or are you just teaching?
I bet you someone else could tell you exactly what the topic is, but it's in there.
All right.
I don't know the number, but I know it's an important one.
That's fine. So what we're going to do is you're going to scroll to the top. Okay, scroll to the top for a second.
Yeah.
And let's see, you're in your course. Go to where it says assignments. One over.
Right here.
Yep. We're going to try it. Let's see. Now click on add an assignment. There you go. So what was it that I can't even remember? What was it that you said you taught today? What's that thing called?
Let's just say voltaic cells, or non-standard voltaic cells.
Okay, we're going to try something together. Click on, there are 3 ways to create this assignment: generate with AI, import, find in content library. I have no clue, honestly, whether the class companion has chemistry. This is something really new for me.
I looked in the content library. It does have some chemistry, but it doesn't have a lot of AP chemistry, and certainly not in this topic.
Okay.
But I imagine I'm helping build that library.
Looks like you are. So click on generate with AI. We're going to try to see if this works. This will be interesting. And now where it says objective, for those who are new, it doesn't mean like the objectives at least that I learned about 40 years ago when I first took a course to get me ready for being teaching. It just means, what do you want the AI to do? So you taught today. Let's try this. And if you were to go into class tomorrow, check for understanding on how well they understood what you taught today. So 5 MCQs, would that be good?
Yeah,
10?
5, or do I tell it? I've been trying different prompts, so if you have better details, and please excuse my spelling. I am a terrible speller. Thank God for AI. Okay, generate 5 MCQ on non-standard voltaic cells. And then I would say, like, give them the required reduction potentials.
Oh my gosh, the foreign language.
And have them solve for the non-standard E cell using the Nernst equation. Give all appropriate constants. Whoops, there you go. Constants. I can't spell. Constants. And I might I can certainly continue to work on that, but would you want to see what that makes?
Yeah,
all right,
let's take a look. Yeah, generate that.
In previous ones, like I will, any AI system, it's kind of iterative process. Like, no, I want this, and I keep on telling the AI, like, make this adjustment or that adjustment. So let's see.
So first just read that introduction and tell me, what do you think about the introduction? Does it accurately capture how you...
I'll read out loud. This assignment focuses on calculating the cell potential of non-standard voltaic cells using the Nernst equation. You will be provided with the necessary reduction potentials and conditions to solve for the non-standard cells. So that sounds pretty good. Use the Nernst equation. It is giving the Nernst equation in LaTeX, which I hope someone knows how to code, because I don't. It does give the temperature in Kelvin, the number of moles of electrons. Faraday's constant, that's even more precise than the one they provide on the AP equation sheet. And then reaction quotients. That seems consistent with what I was looking for. Should we keep going?
Yep. Great idea. Let's see the question.
Group 1, use the given reduction potentials and conditions to calculate non-standard cell potential using the Nernst equation. Consider a voltaic cell with the following half reaction. So I can read through that. They're having it's zinc 2+ plus 2 electrons goes to zinc metal, and it's giving the reduction potential, which is consistent, negative 0.76 volts. And then the next one is the copper 2+ plus 2 electrons goes to copper, and the E cell is also correct, 0.34. If the concentration of the zinc 2+ plus is 0.1 and the copper 2+ plus is 1, what is the non-standard cell potential? That's perfect, because it engages with the key idea. Now, it happens that the answer is not correct, but we can work on that, right? Just based on what I can see right here. But maybe I have to check my math, but that's my intuition on that one. But should I keep going?
Yeah, let's just take a look and tell me how
that's true for any AI system I've ever used. I always have to, but like it gets better with that process. Okay, a voltaic cell 298 with the half reaction silver 1+ plus an electron goes to silver metal. That looks like the good reduction potential. Iron 3+ plus an electron goes to iron 2+. That's an interesting one. And that's 0.77. That seems right. The concentration of silver is 0.001 molar, and the iron 3+ plus is 0.1 molar, and the iron 2+. Plus, this is extra. I couldn't do that one in my head, so I'm gonna guess it is right, because it definitely looks like it's the lower option. Let's see. No, that would take a little bit of work. I have to pencil and paper that one, right?
Quality of the first two questions, regardless of the answer, are they?
Relative answers are great. They're perfect. They're in alignment with what I would want to make sure my kids actually paid attention and have any sort of brain cells for the past 75 minutes. And it'll give me feedback about okay, did that go well, or which kids need more support, or so definitely the quality of the questions is great.
Let's look at C and see if this pattern continues, because I'm finding this pretty fascinating. I've never done this before with Cam. Yeah,
and it's very objective to a degree, right? I kind of like chemistry that way. There's always an answer, usually. 298, consider to have cell reactions with nickel 2+ plus 2 electrons, because the nickel metal, the reduction potential is negative 0.25 volts. Lead 2+ plus 2 electrons goes to lead metal with a reduction potential of negative 0.13 volts. If the nickel 2+ plus is 0.05 molar And the lead 2 plus is 0.2 molar, calculate the non-standard cell potential. It's great because it continues to this pathway. And I like that in this one in particular, it picked 2 different half reactions that have reduction potentials that are negative values. The equation that they use, students are supposed to use, is E reduction cathode minus E reduction anode. And oftentimes it confuses them. Right now, the outcome of the E cell should be positive without giving you a too big science or chemistry lesson. But what confuses kids is when you're putting in 2 negative numbers, they're like, wait, no, that should be positive. Yes, the output of that equation will still be positive because one is going to flip, right? Because negative times negative. But the gist is, I would do that because I want to make sure the students are prepared for the possibility that like both of the reduction potentials you're using are negative.
Okay. Question. Sorry.
Yeah. Keep
Question
going?
4. Yeah, we're
right.
going to look at this one and just assume then, yeah.
Aluminum 3 plus 3 electrons goes aluminum. E cell is negative 1.66. That's right. I happen to be doing aluminum reduction potentials today. I don't have these memorized, but these are questions that are addressing ones that like. Another point I would make is that it seems to have picked reactions or reduction potentials that correlate with the questions that I probably would present in class. And that it's not like giving some like random one that's like, permanganate or hydrogen peroxide, which are not bad ones, but like harder. And that would be like level 2 in terms of like using this for another future class. Keeping on. Come again?
Not to put words in your mouth, just to make sure that I understand. So that last comment was, so I'm understanding, is that the questions that are being generated basically reflect what you taught in class, though the AI wasn't in the classroom with you when you taught. Was that what you were saying?
Yeah, in the context of my prompt, that's correct.
Okay.
And it's addressing some of the things that, as an AP chemistry teacher, I would want to introduce. They're not really like from the perspective of probably an experienced AP chemistry teacher or chemistry teacher, twists and turns. But as a student, some of my, I like to take pride in like thinking like a kid. Sometimes it's bad, sometimes good, right? Like, what are the things that have interfered with my students' ability to get the correct answer or process it in the past? One of these things is like the double negative E reduction potentials. Not the biggest jump in the world, but for someone who had just learned it, that's something I would address. In this case, they're presenting reduction potentials that are consistent with the ones I use when I start this topic. So it is, without even being my classroom, kind of using some of these reduction potentials I used to say in class, literally. I can show you my board, and it has them on there. Is it spying on me?
Is it what?
Did it see my board? Keep going.
I got it. I said this is the first time I've done something like this with a chemistry teacher, but I did present to a room full of AP teachers this past year. I think it was in December in Chicago, and there were a good chunk of chemistry teachers in there. I didn't get a chance to look at it like this, but actually you're reminding me they had a similar kind of reaction that for checking for understanding, it was relatively spot on. We're going to get to that first question in a second. Let's try something. I'm going to assume that the others are in that same pattern with you. Can you scroll up for a minute to the very top again? And what we should be able to see is a choice there. Let's see. Scroll up even further. Can you go up even higher or not? Yep. So it should say, there we go, preview as student. Do you see that at the very top?
Yep, I just clicked it. That one right there?
Yep, and now click, go ahead, and this is how it's going to look from the student end. And I want you to scroll down to any one of those questions, pick a right answer, pick a wrong answer, and let's just see what happens. So
I'll just, I don't know what the real answer is, but I know 1.1 volt is like it's like the generic example you go to. So, but I'll just hit submit right now. It's going to tell me that's wrong. Maybe you chose 0.92. Should I read it?
Sure. Well, yeah, yeah, sure. Because this is for the benefit of chemistry teachers. Yeah. So sure.
If you chose 0.92 volts, but let's think about how we would calculate the non-standard cell potential using the Nernst equation first. Remember to calculate the cell potential by subtracting the reduction potentials of the anode and cathode. it's correct, and the equation is correct, then use the nurse equation that appears to be correct in LaTeX, making sure you calculate Q correctly using the concentrations given, and check the values you're using for R, T, and F. Double check your calculations and see if you arrive at a different answer. That's pretty consistent with the guide I would give a student in terms of what they need to be looking at if they did not get the correct answer.
Now, this was question number 1, right? And wasn't it that you
Correct.
said question number 1, the key showed the wrong answer?
Yeah, you want me to work it out?
No, I'm just curious here. So I don't recall whether, let's see, how am I going to phrase
Number
this?
1 was objective, because I happen to know this particular example because it's the one that, like, we generically, like, every chemistry teacher in the world who has any experience working with electrochemistry and voltaic cells, we start with the zinc and copper one. If you ever had like a potato clock growing up or like a lemon clock, like you got a piece of zinc and a piece of copper and you stick it in that thing. And in fact, I did a lab. I had a play day where I just bought like a bag of potatoes and kids sticking metal into it. But so the copper zinc one, I happen to know is 1.10 volts when it's standard. So my expectation is when it's non-standard, it can't be that number.
Okay, so the key is incorrect, right?
That's correct. And I don't know about the other ones, but certainly I've had experience where it's been correct in other examples, like the ones.
And now that we're showing it from the student view, if I'm a student and I'm as bright as you are, I would conclude, based on what you're seeing on the screen here right now, that Class Companion is off in this particular instance. Is that right? That's what I should be concluding?
Correct.
So
I think, go ahead.
My question to you is, if a student, I'm going to be the student in the class right now, if I were to say to you, oh my gosh, I don't think this is right. I should say that, right? I should say, if I'm a student, that's what I should say to myself. Right?
Previously, it was one of these things. It had one of the questions, like I had to get 5 like short FRQs, not like a big FRQ, like, you know, I guess one FRQ with 5 parts. And one of the one I showed you before, it was like just like a 0.02 off. And when the kids put it in, like, Mr. Irvine, I did it right, but it's saying this. I'm like, don't worry, I'm gonna go check it later. Like, keep going, right? But like that's like the human auditing the system. But everything else was right. So I mean, I'll take it.
If I'm in your class, thank you. Okay. So everything else is right. So if I'm in your class right now and I go, oh my gosh, this thing is wrong. How do you as a teacher handle a moment like that? How would you handle it?
Well, in the context of how I'm using this as like that extra credit kind of exit ticket quiz, you know, unexpected, but most like they're incentivized by wanting to get that, you know, extra credit point. So I say, hey, look, you know, keep going. I'm piloting this tool. You know, that you guys know that Mr. Irvine's into these things and like they're not perfect, but they're good. And I'm going to go back and I'm going to make sure that you get credit for if it was right. And so I tell them, keep going, because I'm trying to keep them on a time crunch. I say, you know, please, like, you know, certainly glad you brought it up, but keep moving. Because Mr. Irvine is, you know, not going to just trust it completely, but I will audit it as well. And when we do the rubric part as well with the free response, like the first time I did, like I forgot to check the grammar thing. I don't do grammar, right? You can see from my spelling before, grammar bad, me English no. So, you know, getting to know a tool, it takes a while. It's a learning curve, right? So I just tell them, keep going. Don't worry about it. I'll take care of it.
Okay. And in whatever time, whatever number of MCQs that you have given checking for understanding, what have you found to be, let's just say, the accuracy rate in terms of the answers? Are we talking 90%, 50%, 25%?
I was at least 90% right now.
Interesting. For chemistry. I mean,
you know, one of the things is like it's objective, right? They're numbers and it's math, right? And
I hear you say that, but I'm on this AP and I'm on this AI in, what's that thing called? AI for Teachers Facebook group. AI for Teachers Facebook group. It's 500,000 members. Yeah, everyone really should. 500,000 members. The admins of that group they're fabulous. They're fabulous. They keep that thing moving forward so well. And any question you have, you just go up there and you're going to find really talented people and people that care and are well into this responding. So the one thing you always are here is AI is a large language model. It doesn't do math and it doesn't do science. That's what you hear. But then they'll come along and go, no, it's gotten way better in just a year. It's gotten way better in 6 months. And what you're telling me, here we are in January 2025, it seems like it's doing science. It's at least 90% of the time with multiple choice, it's doing science, is what you're telling. Imagine where that would be next year or the year after.
I didn't get that memo that it didn't do science in the first place. No one told me. So
well, that's 2.5. That's 2 years ago. Yeah, 2 years ago. Yeah.
I just was like, hey, wait a second. There's a tool that can make my life easier, right? Yeah, I'm going to use it, right? And we have enough going on as teachers, right? Like, I don't want to recreate the wheel every single time I think of a new question, right? And there's lots of test banks and stuff like that, but even those get old. And I want a little creativity. And yeah, the kids have access to things like Chegg and whatever, right? And and as an AP chemistry teacher, there's these publicly available questions. And sure, there's AP Classroom, but which has this sequestered questions. But ultimately, I can only use those as conditioning to a point. I think it's kind of, when I first started, we would use other AP chemistry questions as quizzes or other resources, but those are out there. And if a kid has memorized every single question, good for them. But the way to really make sure they're ready is get them ready for something they've never seen before, which is essentially the AP test itself.
Based on what you've shared and shown me here, and based on what I heard, again, it was a large room, and I only had a few minutes to get over to the AP Chem teachers in December over there in Chicago. Based on what I'm hearing from these two experiences, there seems to be real value and benefit to checking for understanding, using Class Companion to check for understanding an AP chemistry course. That's the message that I'm getting. But we're going to take this thing out for a test drive right now. Okay?
You tell me, right? Tell me what to do.
So is there ever, in the AP Chem course, do students ever have to write? Is there any short answer?
Yes, there is.
Oh my gosh. So you know I'm going to ask you to do it. I mean, you and I, we certainly didn't chat about this beforehand. Go to, let's go back to create an assignment. We're just going to go back, add an assignment. Are you going to do it by AI? Oh, this I have to see. Are you going to do it by generating?
You tell me. You tell me.
Well, if you have one handy and you want to import it, we could do it that way.
Oh, I can make this up. I got enough experience that I can figure it out, right? I mean, but in terms of you want it like in the AP chemistry fashion, or do you want
let's explore. I just want to see.
Let's see what it comes up with.
Yeah.
All right. So the topics where there's writing in AP chemistry is like intermolecular forces, where you have to describe why this molecule has, and how it interacts with its, other molecules of the same type, and why that impacts the boiling point, or how easily evaporates, vapor pressure, or viscosity, like all these physical properties of materials, mostly like liquids and gases. There's a little bit of solid structure, but I'm going to say, should I push it, or should I go with like a low key one, as the kids say? Should I go high key, low key, no cap, high cap?
We're running a test. Take it wherever you want.
I'll say, should I give it like a free response? I guess we did a multiple choice. Let's try to FRQ.
I think so, right? Yeah.
All right. Give me a 4-part FRQ on intermolecular forces in the style of AP chemistry. Focus on varying physical properties. Excuse my properties. English not okay. Like boiling point, Let's do vapor pressure and solubility. Let's see. Let's give. I guess it won't be able to give a molecular structure because I don't think it can generate images. But give small molecular compounds and ask the students to compare which has the higher, I guess, value for the given property. And I'll give it a twist. Choose molecules with different, or choose molecules, one that's polar and has H bonding, and one that is non-polar but has higher boiling point because of its polarizability. Polarizability. Let's see what happens. Also, solubility in a polar solvent that's not water. Ready to go?
I'm ready.
I can spell the word because, but sometimes I just don't. I mean, AI it can do auto. It understands whatever I put in there. It's like, who needs spelling anymore?
Exactly. But don't
Sorry,
tell me.
yeah, spelling is important. Never mind.
All right.
Don't tell my 12-year-old. Okay, let's see. This time we focus on the relationship between intermolecular forces and various physical properties such as boiling point, vapor pressure, and solubility. You will compare small molecular compounds and analyze how their intermolecular forces influence these properties. Ooh, let's go. Consider the following pairs of compounds and their physical properties. Analyze the intermolecular forces present and determine which compound in each pair has a higher value for the given property. Compare the boiling points of methanol and ethane. Those are correct. Which compound has the higher boiling point and why? So I guess that's a good starting point. I'm not sure. It hasn't integrated that twist that I tried to put in there. The gist of it is you think molecules that have stronger forces should have a higher boiling point. But you can give really big molecules that have higher boiling points that are non-polar. I have an acronym that I call it, but this is a Mr. Irvine. I'm copyrighted right now. I call them BAMs. They're big ass molecules. All right. I tell the kids, if you write that in the AP exam, I'm going to get fired. So please don't. But let's see if it gives it a BAM. All right. Compare the vapor pressure of dimethyl ether and propane, which has the higher vapor pressure and why. That's good. Diethyl ether does have polarity. A lot of kids think the vectors cancel out. Propane is non-polar. So the answer for number one should be methanol because of hydrogen bonding. Answer number B, vapor pressure is inverse the forces. So you would expect propane to be the answer. And it's asking why. So that's going to be an interesting twist because I haven't tried that yet. How it's going to analyze their writing. And that could save me a lot of time if it can do it right. The solubility of acetone and hexane and ethanol, that's a great one. So it did manifest that solubility. I didn't want water. I like water, but it's very generic. And I want to make sure that students have to think beyond just memorizing that water is polar and has hydrogen bonding. So that's a good one. And there's a twist. Part 1D, maybe. I don't know, maybe not. We'll find out. I'd have to look it up. But neon and hydrogen fluoride are not too far away in terms of masses. So I think, I don't know which one is a twist or if it got integrated at all for the BAM. What do you want to do next?
Well, let's just, ChatGPT, AI, Class Companion, it's all about, as you said, iterating. We're not going to go back and iterate at this point, but this initial output, analyze in terms of the quality. How
great. I love it.
Okay.
I might have to use it as I'll save this one for exam review for my, all my kids, right?
Let's scroll to the top and look at it from the student preview as a student. Okay.
Oh, it's missing a rubric.
That's right. So what we're going to do now is, have you gone down this path? Have you tried them this before?
I did do the rubric for the other ones, and they were much more objective with the free response for like the questions I was generating. They were math, right? It's there's like, here's the number, right?
So
so when I first tried it, I didn't realize that when I generated the rubric, it would also be asking the students to show work. Like, how did they come up with the answer?
Okay.
And that was one of the things in my first trial of this. Like, Mr. Irvine is saying it's wrong. I put the right number. And I'm like, oh, well, okay, just keep going. And I ended up, soothing their concerns. But the gist is that the rubric was looking for a specific thing. So next time I paid a better attention and I said, okay, make sure you show the calculations. And so, no, I have not done it for like writing components. So that's a new journey for me.
Let's click on that add rubric. And you're going to get the same three choices, generate with AI.
Generate with AI. Thank you very much.
Yeah.
Okay. So now, okay, this is the part I take off, right? Because I guess we're not in English class right now. But, it depends on like what I want. I guess like, I don't think the AP chemistry graders would remove points for grammar or spelling. I think they take a lot of like, you can paraphrase or bullet point, but I have to double check on that. But I'm gonna get it out because I got enough going on with the chemistry. So I'm gonna say, give me some direction, Peter. What do you think I should say?
Oh my gosh.
Not the chemistry wise, but like in terms of like what I should have it focus on.
How about something simple like give me a 3-point rubric, great answer, well above expectation, I don't know, 2 somewhere in the middle, and 1 well below any kind of real scoring bar, I guess.
Answer with clear and explanation using the correct terminology.
Something like that.
Terminology. 2 equals, I guess like average or medium answer with correct terms, but not as detailed. 1 equals correct answer without explaining, and then 0 equals wrong answer. 0 equals wrong answer. Does that sound reasonable?
Yeah. Let's do it.
We're gonna try. Boom. So, okay. Incorrectly identifies the intermolecular force, but not one for one compound, but not the other. Correctly identifies the intermolecular forces for both compounds in the pair without clarity. Accurately included identifies the intermolecular forces present in both compounds in the pair using correct terminology. That seems pretty good, and it seems pretty consistent across the board. And so that would be consistent with what I would want from this system. 1, 2, 3. Okay, let's see. Oh, and here's the details about your
twist.
The boiling point. The higher incorrect determines which compound has the higher boiling point. Provides no justification for physical properties based on intermolecular forces. So it seems pretty good. Give it a try.
Yeah,
I've never done the add criterion thing, but should we try it or keep going?
Not today.
Okay.
Just if in the interest of time, but it does significantly increase the quality of the AI to score. But we're just going to stay right where they are. Go ahead and create the rubric. Finish.
Okay.
Uh-huh.
All right. Ooh, okay. Choose. All right. So short answer rubric. We got it right there. Essay. I do not want to do essays today.
So now preview as a student. It should work.
There you go. Okay.
Oh my gosh.
Come on, big money. Make it work. There we go.
Totally uncharted territory for me.
Yeah.
And now, yeah. So I'm going to count on you. Did you?
Oh, you want me? They're going to grade myself?
Yeah.
Come on.
Yeah,
No
let's see what
pressure.
happens. And
Let's
even,
see what the
feel
universe says about
feel-
my student skills.
and feel free to put in an attempt that barely gets it over any kind of bar, 1, 2, or 3.
So a second semester senior. Got it. Okay.
Yeah, perfect.
Um,
Or better yet, like I might answer if I were in your class. Same thing,
wait,
right?
then you're up, Peter.
Yeah,
I'll do a good one, and then you can have the next one. How about that? I can type it for you and everything.
There.
I'll even misspell things on purpose.
I do karaoke. That's about as far as I go with putting myself out there.
All right. Compare the boiling points of methanol and ethane. Which compound has the higher boiling point and why? So I'm going to say methanol has the higher, come on, brain, higher BP because it has hydrogen. Come on, brain. I wonder if it uses H bonding. H bonding, whereas ethane's strongest force is LDF. It's London dispersion forces. So I'm trying to see if it gets the accurate, like those abbreviations. H bonding is generally stronger than LDF, which and boiling point is directly proportional to IMF strength. Okay, let's see what happens. Should I just hit submit?
Please.
Okay, please don't judge me too much. Oh my gosh. Boom, I win. Well, thank you very much. I knew I belonged here.
Take a look at the quality. We're going to try something. Take a look at the quality of the response. Take a look at the response and tell me what you're thinking about it.
Great job. You accurately identified the intermolecular forces for both methanol and ethane. You correctly noted that methanol has hydrogen bonding and ethane has LDF or London dispersion forces. This shows a clear understanding of the type of intermolecular forces present in each compound. Comparison justification, excellent work on providing a clear and detailed justification for the difference in boiling points. You correctly explained that hydrogen bonding is generally stronger than London dispersion forces, and you linked this to the boiling point being directly proportional to intermolecular force strength. This shows a strong grasp of underlying concepts. Application to property comparison. You did a fantastic job determining the methanol has a higher boiling point. Your explanation shows a consistent and accurate application of the concept of intermolecular forces to predict physical properties. Keep up the great work. You must be doing something great.
Now, let's try something. Copy any of that, copy all of that. And let's assume you're a student that doesn't fully comprehend that. You want that explained in simpler terms. You see that little green icon down bottom right hand? That is what it's called.
The ditto thing?
Yep. Did it activate for you when you click on it?
It's there. You want to click it?
Yep. Yeah. So have you explored Ditto yet?
I haven't.
All right. So think of Ditto as a tutor. Okay. Imagine you're in a class. The students have received this response. Before the age of AI, someone wants an explanation they don't understand. Someone else wants an explanation. But here, the student could theoretically pop the explanation right into Ditto and say, explain this to me in simpler terms. I'm curious if that would work for chemistry. I know it will for the other subjects, but you're going to copy, you're going to explain, and then you can copy and paste in the response. And I'm curious if it'll come up in simpler terms, simpler language, or at the very least, another way of explaining it.
Mm-hmm. Should I give it anything else other than simpler terms? Like
that should do it. Yeah.
And I know my students and don't be wordy. Should I do that?
Perfect. Yeah. Don't be wordy. Yeah. I was looking. That's the
you press Shift Enter. Sometimes I'll just copy and paste it. Right. Oh, I didn't get it all, but it's enough. All right.
Okay.
I didn't even know that. Okay. We'll find out. Awesome work, Andrew I. You recognize that forces in methanol and ethane are correct. Methanol has stronger hydrogen bonding, while ethane has weaker. Keep the great work. Keep up the great thinking. What do you think these differences mean for their boiling points? So it's asking me to reflect on my own stuff. Should I keep going?
It didn't really explain the explanation in simpler terms, the feedback in simpler terms, did it?
No, I think it seems to be leading me down a path of me through the. I imagine there's a dialogue that would happen if I keep on going.
It would,
and it would
yeah.
kind of keep on like, it's probably, what you might do as a teacher. Well, what do you think about that? Right? Like,
yeah.
And getting them to kind of generate their own version of that understanding.
Ditto is a new feature, and I'm kind of exploring it along with you here. To what extent can it explain the feedback in simpler terms and in less wordy terms, just as you pointed out? And by our little experiment here, I'm concluding it didn't quite do it. So I'm going to be checking back with Class Companion and saying, does it do it? And if not, can we get it to do it? I do know that in the settings feature, and I don't know if this would affect your class, but in social studies, what I can do is I could say, make sure that when they use Ditto, that the Ditto can give them the feedback in language of their choosing: Spanish, German, French, whatever the case might be. Chinese, yeah, which is pretty cool.
That's cool.
Okay, but what we learned here is, at least initially, with one SAQ, with one short answer question, it was able to, the AI create a relatively good set of quality questions. Or am I putting words in your mouth?
No, I would agree. I think it's a great, with more like iterations and work. I mean, my learning curve at this is not too steep, right? It's pretty much like instant access into its features. And as I move forward, I probably like stretch it and see how far I can push it. But I probably, or I do plan to use it in my honors chemistry coming up too, because that check for understanding, or some other way of some exit ticket, some tool to kind of like, hey, like I'm going to be assessing, with or without a grade, how you're doing on this stuff, will keep them awake, independent of my own personality. But I like it. I think it's a good tool. And
so I think you answered my question. How have your students reacted to you putting this in front of them?
Initially, I think there was some grumbling because I didn't understand the rubric tool as much. And that was, I commented on that before, that like, keep going, right? In the context of the way I was using it. The second round, people were happier, right? I think so. For me, that whole feedback part, I think I need to make sure that I'm becoming more familiar with how it works and how I can tweak it, or like you said, like the add criterion thing, or. But I think I plan on keep on using it. I will use it again, and then I'll probably think about other ways I can use it beyond just that exit ticket. Right. I was just looking for a place where it could fit in right now. But one of the things I really like is it does the grading, right? Like, independent of like it making the questions, I haven't found any other system that does the grading for me. That is a new thing. And that was one of my interests is into AI, certainly other reasons, but I think ultimately grading is a huge time commitment for me. I mean, last night I spent 3.5 hours grading my buffers AP chemistry exams, and I only had 30 of them. It's a lot of time. I know that some teachers might find that challenging or not like the idea of handing that control over, but I'm not going to just like let it do the grading and walk away. I want to check, right? But it'll streamline it for me, do the bulk of the work, but there's still a human behind that computer that's going to be, and I've had a few faux pas earlier this fall using other AI systems to generate, answer keys. And I use it as a tool of, or an opportunity to learn about Mr. Irvine's mistakes. But right now, I think it's great.
And you had mentioned to me somewhere along the way that you've shown your staff or other teachers at the school. Was it just the science teachers, Class Companion? And so you want to tell us that story and how they reacted to it?
So I, more like accidentally become a little bit kind of in some ways, spokespersons of using AI and my chemistry classes. And for this particular quarterly, we have, instead of a faculty meeting, faculty and other members of the community can volunteer to showcase some sort of technology or education or ed tech tool or something in that kind of arena. And I showcased Class Companion to a group of, I think, about 40 teachers on Zoom, and showed them how I had used it for my class as an exit ticket, commented on the learning curve on the rubric, teachers all the way from lower school Spanish all the way up to, I think a teacher told me they're going to try and use it in their history class, right? So, I think these tools are out there, and I think if you see someone else doing it, then okay, well, that seems like something I want to try, and that's how you got me into it, Peter, right? And people asked, like how did the kids respond to it? I commented on the rubric, but any new tool, any new system is going to it's going to take some time to figure out. So I said, just keep them going, reassure them, yes, this is a great tool, and yes, it does integrate AI. But with any AI tool, at least in my perspective, I'll always make sure that there's a human at the end point before the grade, right? Because they want to know that, right? And then, but 90% of the work is done for me already. It's just to make sure it's doing it right. So it's a lot of positive feedback, and I think I'm slowly chipping away, maybe that's too negative. Slowly helping people understand, other colleagues and people in education understand that these tools are out there and they can make your life easier. And in theory, then you have more time to focus on your craft of teaching. What are you doing in the classroom as opposed to using that time grading or coming up with new questions, right? It's a typewriter, but a really fancy one in my perspective.
And Andrew, there's I'm sure you're aware of this, there's a AP Chemistry Facebook group. And I would imagine 3,000, 4,000, 5,000 teachers on there. If you were to share either a recording of this webinar there, or if you were to share what you have in writing learned about AI, Class Companion, et cetera, how do you think the majority of the AP Chem teachers would react? Any ideas?
I would start with a subset of my colleagues in the science department here at Harker. I think I have a few other colleagues who have been, potentially because of my kind of enthusiasm for it, starting to use it. I have one bio teacher who's tried and generated a few good quizzes. I think that there's probably two camps. One is maybe a little bit more resistant to the idea of that. Maybe they don't trust it, right? That it's hard to trust new tools, and chemistry is a hard subject, right? It's not. I tell you, I start the year and say, okay, with the parent back to school year parents, I say most humans don't love chemistry unless you had Mr. Irvine, in which case I'm going to blow something up for you and make it fun, right? But I trick them and I pull them in, and then I can drag them across the finish line with that engaging part. But I would say that I imagine there'll be some resistance because it is an interesting kind of niche that pulls together these very abstract, objective and analytical topics. And there's also, I think it's baseline, maybe perspective that something like AI can't do what we can do as chemistry teachers. And I'm not saying it's going to replace us. I'm going to say that it's a tool that's going to make me a better teacher. My AP chemistry teacher was Ron Perkins, who, if anyone does watch us in the AP chemistry Facebook, they'll know Ron Perkins. He was one of the a notable figure in the AP chemistry world, and I think he's still involved to this day. He started a company called Educational Innovations, and I was his last class at Greenwich High School in Connecticut. And I imagine he seemed to be an innovative guy, and I bet you he would be on top of it. I imagine he might be already if he weren't retired.
He founded Educational Innovations? I
believe so. Let's fact check that for a second, but I think he was one of the people involved in that. Yeah.
I'm going to check it too, because I think I just met with them 2 days ago. So I have to find a Yeah, yeah.
So, should we fact check it live? Maybe we
Yeah.
can do that later.
That
But
would
I
be
know,
interesting.
I mean, he does. So he was, I remember I was talking to my colleagues when I first got to Harker, and one of my colleagues, I mentioned, I had my recommendation letter on my wall behind me from Ron Perkins, and you got taught by Ron Perkins? And I was like, oh yeah, I didn't know he was such a big deal. He's a great guy, and I told him I was an AP chemistry teacher, and I'm really grateful for the passion he shared with us. And I'm using some of the tips and tricks that he used with me, with my current crop of seniors and juniors. But the point being is that I think he seemed to be innovative. And I not to say that people who aren't into it aren't innovative. Like, I don't want to have like a negative, like everyone do their own thing, right? But like, this tool is out here, and it's, the box has been opened, and it's a matter of just like, this will make your life easier. Yeah, there's a learning curve, and yeah, you got to get into it a little bit, but like, once you get into it, like, it'll make me a better teacher. And ultimately that's my end goal.
Wow. Andrew, I was not a science kid in school. I was social studies and English, but I really do, listening to you, I do think that I probably would have enjoyed science if I would have had you as a teacher. It's just fun listening to you. And I'm intrigued by how far you have gone with this. I want to offer you this up here publicly right now. So I'm scheduled to speak at the AP conference this summer. I'm also planning to speak at the College Board Forum. Both topics have to do with how AI is revolutionizing AP education. And no matter how far you now go with this, even if you don't move it at all forward, I would love to have you co-present with me at either one of those two, just to share what you've concluded, what you've been learning about AI in education. Can't roll back the clock and be in your class, but I can move this forward.
Yeah, I'll do an explosion for you after we get off the webinar.
Just keep going. It's interesting. Keep going. And I look forward to carrying on the conversation. We're at the end of our hour, unfortunately, right now, or I'd go even further. I want to thank you so much for giving up your time today and sharing all of this, and look forward to seeing you again. Best as we go down the backstretch of the year, and good luck to you and your students on the test.
Well, thank you, Peter. I appreciate your passion for this topic, and I'm glad I found you, or you found me, or one way or another. And I look forward to working with you more, and exciting to share, right? Like, frankly, like I'm doing this with or without sharing it. So if anyone benefits from this, great. And if other people are into it, that's fine too. But if you want to learn more, reach out to Peter. He's got a lot of cool tricks and tips and ideas.
Thank you. And if you know of any other science teachers experienced with Class Companion, or even just starting off, let them know. Send them my way, and I'll interview them. We'll see where we can take it.
Definitely. I imagine I got a couple takers from the presentation earlier last week. So I'm curious to see what they do with it.
Great. Thanks again, Andrew. Really
Thanks,
appreciate
Peter.
it.
Take care.
Have a good night. Bye-bye.
You too.